Okay, right. In this video, we'll talk about graph of greatest integer of any function fx. And first and simplest possible question on this transformation is y equals greatest integer of x. And I'll be doing it with very basic things. Suppose my x lies between 0 to 1, then corresponding to this x, greatest integer of x is 0. If x belongs to 1 to 2, then greatest integer of x is 1. If my x belongs to 2 to 3, greatest integer of x is 2. And for this range, greatest integer 3. If my x belongs to -1 to 0, then greatest integer of x is -1. If x belongs to -2 to -1, greatest integer of x is -2. So for certain domain of x, I am getting perfect integers. Corresponding to these domains, I am getting certain integer values. Which means if my x is 0 to 1, y coordinate is constant throughout and y coordinate is 0. So between x equals 0, y coordinate is 0, means itself x-axis. If my x belongs to 1 to 2, then y coordinate is 1. So if x belongs to 2, corresponding to this particular domain, range is y equals 1. If my x belongs to 2 to 3, then y coordinate is 2. So I have actually drawn these values. Okay, the only thing that needs to be done here is discontinuities, point of discontinuities, and I represent those discontinuities by arrows. So let's say at x equals 1, okay, this at x equals 1, y coordinate is 1, but when x is less than 1, slightly less than 1, y coordinate is 0. At x equals 1, we need to choose our value from this and not this. So at x equals 0, y coordinate must be 1, not 0. So this arrow means refusal. At x equals 2, y coordinate must be 2 and not 1. So at x equals 2, this is the value we are talking about. At x equals 2, y coordinate is 2 and not 1 arrow. At x equals 3, y coordinate must be 3, this arrow. These arrows means refusal at this particular point. At x equals -0, y coordinate must be 0 and not -1. At x equals -1, y coordinate must be -1, not -2. Okay. So what we have actually done here, first for certain values of x, means domain, we need to calculate possible integral values of y, means range. So range is integer values, and corresponding to those integer values, we have actually solved domain. And second thing is these arrows, point of discontinuities. How do we actually refuse and what values we need to choose, select. Okay, so rather than doing this by step, we have actually developed one logic, one procedure to it. And thing is, first we need to draw y equals fx. Second thing is draw lines parallel to x-axis, and y equals k, means integral values of y, means line parallel to x-axis and integral distances. And third thing is locate fx equals k on x-axis. On x-axis, which means we need to calculate point of intersection of this curve and these lines and try to locate them on x-axis, those point of intersection. Corresponding to those point of intersection, calculate x coordinates and then locate them on x-axis. Okay, so let's do this question here. Y equals x, this blue line is y equals x, and then I have drawn constant values y equals 1, y equals 0, y equals 2, y equals 3, line parallel to x-axis represented by these yellow lines. Okay, then try to calculate point of intersection and locate them on x-axis. So this is my point of intersection, corresponding to it x equals to 1. This point of intersection will give you x equals 2. This point of intersection will give you x equals plus 3. This point of intersection will give you -1. This will give you -2. Okay, and x equals 0 itself is a point of intersection. Okay, so we have actually segregated our number line into different segments. What? Between 0 to 1, x coordinate 1 to 2, coordinate 2 to 3. These are different domains. Between 0 to -1, between -1 to -2. Okay, so when x is between 0 to 1. X coordinate is between 0 to 1. Y coordinate fluctuates between two constant values, y equals 0 and y equals 1. Graph is increasing from 0 to 1, but within these two limits, y equals 0 to y equals 1, which means greatest integer is 0. So when x is between 0 to 1, y coordinate fluctuates between these two lines. Okay, y equals 1 to y equals 1 to y equals 0, and lower value is 0, so y coordinate is 0. Between 1 to 2, x 1 to 2, y coordinate fluctuates between y equals 1 to y equals 2, greatest integer of x, it would be 1, then 2. Between 2 to 3, y coordinate is 2 to 3, so greatest integer of x, it would be 2. Likewise, when x varies between -1 to 0, y coordinate is between these two constant values, and greatest integer of it is lesser integer, which means -1. When x is between -1 to -2, y coordinate must be -2. Okay, this we have successfully done. The only thing is what to refuse and what to accept at these particular points. So at x equals 1, y coordinate must be 1, not 0, means refuse. At x equals 2, y coordinate must be 2 and not 0, so refuse 1. At x equals 3, y coordinate must be 3, this point, not 2, means arrow. At x equals 0, y coordinate must be 0, not -1. At x equals -1, y coordinate must be -1, not -2, refuse. This is my graph of same graph, greatest integer of x. Okay, second question is this greatest integer of x square. I have drawn x square, then again y equals 0, y equals 2, y equals 3, y equals 4. Corresponding to these point of intersection, these are point of intersection, this point, this point, this point, this point, this. Corresponding to these point of intersection, we have located x coordinates on x-axis, 1, under root 2, under root 3, under root 4, which means 2. Likewise, on negative side of it, graph will be symmetric about y-axis because x has got even power. Okay, so let's talk about right hand side, and left hand side will be much easier then. Between 0 to 1, when x is between 0 to 1, y coordinate fluctuates between y equals 0 to y equals 1. This is my increasing graph, 0 to 1, varying between 0 to 1, which means integer part is 0. Between 1 to under root 2, y coordinate fluctuates between 1 to 2, which means 1. Between under root 2 to under root 3, y coordinate must be 2, not 3. Okay, under root 3 to this. See, the first difference is at this particular part, these steps have got same width, but now this particular graph has got 0 to 1 length, then length is decreasing, however y coordinates remains same. And again between 0 to -1, y coordinates is varying 0 to 1, so 0. Between 1 to under root 2, graph is increasing, this is my lower value. Okay, right. What about at x equals 1? At x equals 1, if you put x equals 1, 1 square is 1, value must be 1, not 0. At x equals under root 2, value must be 2, not 1, so arrow. At x equals under root 3, value must be 3, not 2, and this. Likewise, because x square, even if you put negative values, at x equals -1, value would be 1, not this. Minus under root 2, value must be 2, not this. Likewise, what about x equals 0? Suppose you move slightly at x equals 0, y coordinate is 0, but if you move slightly towards right hand side, okay, the y coordinate is slightly greater than 0, but again greatest integer of it would be 0. This is the reason at x equals 1, even if you move away from it in either direction, y coordinate will be 0. We are talking about greatest integer of it, so least possible integer. Even if you are slightly increasing your y coordinate, it doesn't really make any difference. This is the reason at y equals 0, this graph is continuous. This is discontinuous at 1, under root 2, under root 3, under root 4, but not at 0. This was discontinuous at every integer. Okay, good. Third graph, x square we have done. Now greatest integer of x. Okay, same thing. The only thing is now v shape I have actually done, and I'll try to be very swift and let's see if you can understand it. This is v shape. I've already located points on x coordinate 1, 2, 3, minus 1, minus 2, minus 3, and this between 0 to 0, 0, 1, 1, 2, 2. What about arrows? This, 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 this. But at x equals 0, graph is continuous. Again, graph is symmetrical about y-axis. Why? Because x square is even power, modulus x is again symmetric. What about greatest integer of sin x? Same principle, draw sin x. Then because sin x lies between minus 1 to 1, the only possible integral values are minus 1, 0, 1. Because sin x is periodic and period is 2 pi, this graph of greatest integer of sin x will be periodic and period will be 2 pi. Okay, so finally we have located 0. Okay, 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, minus pi by 2, minus pi, minus 3 pi by 2. Point of intersection with minus 1, 0 and 1. Okay, between 0 to pi by 2, 0 to pi by 2, graph is increasing between 0 to 1, but we need to choose lower value. This is my value. Between 0 to pi by 2, greatest integer is 0. Likewise, pi by 2 to pi, even if graph is increasing from this to this, greatest integer is 0. And graph is decreasing from 1 to 0, we need to calculate the least integer, chota wala value, smaller value. Okay, right. In fact, between pi to 3 pi by 2 and then 2 pi, graph is between 0 to minus 1. We can safely say this value is throughout is minus 1. Okay. And what about this? 0. 0 to minus pi by 2, y coordinate is minus 1. Sorry. Between minus pi by 2 to minus pi, y coordinate is again. Between minus pi to 3 pi by 2, y coordinate is 0. Okay. Let's talk about discontinuities. What about 0? What about x equals 0? If you put x equals 0, sin x must be 0, and so one possibility is 0, one possibility is minus 1. It cannot be minus 1. So arrow on this particular side. What about pi by 2? At pi by 2, y coordinate is 1, which means greatest integer of x, it must be 1. But if you slightly move in either direction, greater than or smaller than pi by 2, y coordinate is slightly less than 1, which means greatest integer must be 0. So discontinuity on this side and again this side. What does it mean? Means you are moving from this to this, but when you are actually approaching pi by 2, y coordinate immediately jumps from 0 to 1 and then again decreases. So discontinuity on either side of pi by 2, but at x equals 0, there is only one kind of discontinuity, which is left hand discontinuity. Okay, and at pi value must be 0, not minus 1, so arrow. At 2 pi value must be 0, not this, arrow. What about 3 pi by 2? At 3 pi by 2, y coordinate is minus 1, right? If you move slightly beyond this 3 pi by 2, y coordinate is slightly more than minus 1, but again greatest integer of it will be minus 1. This is the reason graph is continuous here. Okay, graph is continuous here. At minus pi, value must be 0, not this. This graph is discontinuous at 0 because of left hand discontinuity. At pi by 2, graph is discontinuous because value is 1 but discontinuity on other side of it, left hand discontinuity, right hand discontinuity. At pi, only right hand discontinuity, left hand side is continuous. 3 pi by 2 graph is continuous, and 2 pi left hand side of discontinuity because value is 0 and limit is again 0, but left hand limit is -1. Okay, what about greatest integer of cos inverse x? Again same principle, draw cos x, draw integral values. Cos inverse x has range 0 to pi, means one of the integers could be 0, 1, 2 or 3, only 4 possible values. Okay, corresponding to these values, one coordinate is y equals 0 gives you 1, y equals 1 gives you cos 1, y equals 2 gives you cos 2. Cos 2 is negative because 2 is in second quadrant. Cos 3 is again negative. So 4 different 4. 1 cos 1, cos 2, cos 3, cos -1. 1 cos 1, cos 2, cos 3, -1. What about 1 to cos 1? 1 to cos 1 graph is fluctuating between these two y coordinates, which means lesser value. So 0. Between cos 1 to cos 2, y coordinate is moving 1 to 2, which means throughout this range you have y equals 1. Between cos 2 to cos 3, graph is moving between these two y coordinates, so value is 2, and then this value is 3. Okay, what about discontinuities? At 1 we don't have any discontinuity. At x equals 1, y coordinate is 0. What about cos 1? There are two possibilities. One of the possibilities is this or this, but at cos 1 value must be 1 and not 0, so discontinuity arrow on this side. At cos 2 value must be 2, not 1, discontinuity. At cos 3 value must be 3, not 2. What about -1? -1, there is no, the domain is, so we need to consider only right hand limit. What about -1? Graph is this throughout constant. Okay, so only cos 1 gives you discontinuity, cos 2 gives you cos 3, -1 doesn't give you any discontinuity, but graph is over 3 to pi, and between 3 to pi the greatest integer is 3. I suppose this will suffice for the this transformation y equals greatest integer of fx. Okay, thank you.